There were two problems on the polar coordinate homework that you had to convert into Cartesian form. And so I want to make sure you guys are clear about the two acceptable versions of the answer. One of them is just full credit, one of them we usually give extra credit for. So remember the process for converting into Cartesian form. You're either going to be substituting or rearranging. So the order that we went in earlier this week, and there's other orders you can go in, but what I did was I replaced sine with y over r. And the reason that I did that is because now this r down here can cross multiply up to that r up there. And so it became r squared is equal to 4y. So I had substituted once, I'd substituted for the sine right here. Then I did a rearranging step to multiply that r up, and now I'm going to substitute one final time because r squared is x squared plus y squared. And so this is a perfectly acceptable version of the answer. That's your full credit answer. That's all you have to do is you have put it in Cartesian form. Okay, Cartesian just means x and y. But if you want to put it in its Cartesian graphing form, and there's serious benefits to it because it can give you the characteristics of the graph, which ideally you would be able to tell straight from the original polar form. But you could do characteristics of the graph. You'll know the center, you'll know the radius, you'll know it's a circle, of course. And of course we're doing a conic unit last, and we're going to have to know how to complete the square. So it's why we're motivating you to learn it now, or to relearn it now. So if you know that it's a circle, which we do, okay, then we know that we want the equation in this form. This is the graphing form from both your geometry classes and your algebra 2 classes. Okay, that's the graphing form for all circles. So what we need is the x's are already a perfect square. There's just a single x term in this particular equation. But I need to make the y's become a perfect square. So I have my y squared here. I move the 4y over to be with it, and I leave a blank to complete the square so that I can make my y's become a perfect square. Now for right now, that makes my equation equal to 0 because I moved the 4y over to the left. But remember that when I complete the square right here with my y terms inside the parentheses, I'm going to have to add something over here to keep my equation balanced. Okay? So you may or may not remember from geometry and algebra 2, the way that you figure out what number goes right there is you take this middle coefficient and you chop it in half and square it. So when you chop it in half, it becomes -2. You square it, it becomes +4. So you have to add 4 to that trinomial, or to make it become a trinomial even, so that it's now a perfect square trinomial. But if I've just added 4 to the left side, I need to also add 4 to the right side. Okay, and actually I'm already ready to write my graphing form. So the x part of my equation that I'm looking for right here is just x squared. Okay, the y part of my equation that I'm looking for right here is the factored form of that trinomial. And y squared minus 4y plus 4 is y minus 2 squared. So you factor it. And then it's equal to 4. So this is the graphing form. Okay? Now remember, as I've told my kids, you don't have to do this algebra right here to put it in its graphing form, because here's your polar form. This is what you started with to begin with. I keep harping on the fact that you need to make flashcards. You need to know, just by looking at this polar form, this is a circle. It's been moved above the pole because sine would move it vertically, and because that 4 was positive, so it's moving vertically in the positive direction. But the 4 is no longer your radius, the 4 is now your diameter, which makes your radius 2. So if you can close your eyes and you can mentally picture this, what you are talking about is a circle looks like that. Not my best circle, but it's got a diameter of 4, so it goes up here to 4, which puts the center right here at 0, 2, and it makes the radius go 2 units in each direction. And this graphing form agrees with that. So if you can look at this polar form right here and you can identify all these characteristics, you can write this graphing form right here without the algebra. You just write it from scratch because you know the center and the radius of that circle. So if I did one more, hopefully more quickly for you guys, because I don't want this to be a full-length video. This was question 25 on that polar coordinate worksheet. So same process. I'm going to substitute. I'm going to replace cosine with x over r. I'm going to rearrange by multiplying the r up to the other side. So r squared is equal to 8x. And then I'm going to substitute again and replace r squared with x squared plus y squared equals 8x. Okay, so here's an acceptable version of the answer. That's Cartesian form. To put it in its graphing form, I would subtract the 8x to move it over here with the x's and leave a blank to complete the square. The y squared is by itself. Right now the equation's equal to 0, but I need to leave a blank to balance my equation. And this time around, the number that's going to complete the square right here is going to be 16, which means this is also going to have 16 added to its side. And so now the factored form of that perfect square trinomial is x minus 4 squared. The y's didn't have anything added or subtracted to them, and it's equal to 16. And so you just want to make sure that your characteristics agree. According to this graphing form right here, my center is the point 4, 0, and my radius is 4. And so if we go back and look at the polar form of the equation, we know it's a circle because we know our types of polar equations. We know it's been moved to the right of the pole because cosine moves horizontally and 8 is positive. It's going to move in the positive direction horizontally. We know that the diameter is 8, so the radius is 4. So that means that we have a circle that looks like this. Our center is the point 4, 0, and it goes 4 units in each direction. That's what gives it a diameter of 8. And so that agrees with the graphing form. Okay, so hopefully that refreshes your memory on how to write the graphing form. You can either do the algebra right here, or you can identify the characteristics of your polar graph and use those characteristics to go straight to the graphing form without any algebra. Okay, remember that the formulas are on the quiz. You're not going to have your unit circle provided for you on the quiz, so make sure that you remember or practice your unit circle values.